dependent t-test, and then we will move on with paired t-test later on. So anyone want to tell me how many sample size we have?
24.
24, thank you. Easy question. Second question, what is IV? Independent variable here.
Mischief. Mischief.
Mischievous acts.
Independent variable and dependent variable.
Oh,
You're wearing a cloak or not.
Cloak of invisibility.
Cloak or not. And then in mischief is dependent variable. So what is the assumption? If you wear cloak, then you're more likely to misbehave. Then if you're not, then they will behave better. That's their assumption. So having that said, everybody got it? IV and DV? So we have two groups. That's why we're doing t-test. Before we go on t-test, first outlier and normality test by group. How do we do that? We could split the data and unsplit it and separately run it. We learned that earlier. That's why we learned that skill very earlier. Or here is another one. I showed you this one too. Go to descriptive, explore. Okay. Did I do that? It doesn't show up. Go again. Come back up. Can you see my small dialog? Okay. So now move dependent variable to dependent list. Group the cork with without it to factor list. Got it? Then it'll generate separate group data. Or you can, if you like to do separately, it's cleaner, split, unsplit kind of thing, you can do that too, okay? Then statistic. So I have a little bit different things popping up until I get used to it. Okay, here we go. I brought it here. We want to check outlier, right? This is what we've been doing it. Then say continue. Then plots. All right, here we go. Then I want to test the normality. What should I click? Right? Yes. Then a KS test, then an SW test. Continue. It gives me option. List what is fine, but we don't have the missing value, so we don't have to worry about it. Continue. And later, if you find out this one has a homogeneity issue or normality issue, you can do the bootstrapping. You got it? Or they recommend to do bootstrapping to get robust confidence interval. But I'm not going to do the bootstrapping now. Then I just paste it. You paste it. I'm going to say okay. No clock, 12 people. It's coming up by group. Descriptive even by group. You see that? Then even skewness kurtosis by group here, one group, second group. All right. Then extreme values by group. Then even test of normality by group. And it's insignificant. Yes, normality is good. Then let's see. No. And I have a first step, outlier normality test by group. Got it? So you have it. Now we are going to do t-test. Analyze, compare means. Of course, independent t-test. Then dialog moved. T-test variable. Boom. Then you need to click define group right there. To tell them, you see that? Small another box. Group 1. So we named 0 and 1, right? So we need to say group 1. First one, I want to say 0. Second group is 1. So the computer recognizes these groups. Got it? Then say continue. Cutting point that you're reading here, and textbook actually explains very well. If you want to split the group based on the median, and you can put the number there, but we're not doing that this time. So just tell the computer what is the first group that you defined. One is 0, one group. The other group we set a number 1. That's what we're telling the computer to recognize our data. That's it. You see that the question mark changed to 0 and 1? Okay. Then options. Let's say what options we have. and we don't have anything. Confidence interval 95% generally. Sometimes if you want to 99, you change that. We're not going to change it. We're going to go with a 95. Say okay. Bootstrapping, you could use it if data has problem with homogeneity and or normality. So you could do it. You could still do it to get robust confidence interval, like I said earlier, and then paste it. Do you see that another one here also? Estimate effect size and paste it so that you have a number, like program. I'm going to just say okay, and this is, do you see it, or what I have to do it again? So 12, 12, and here, homogeneity test came out here. And if it's significant, then you need to be worried. Then you come up with a remedy to fix the problem. Either you do bootstrapping, or you could use non-parametric t-test, or look into the data to help, right? But bootstrapping will help you all the time. So insignificant, I would not worry about it. And then report this t-test. T-value right here, degree of freedom, and this is the p-value, which is insignificant. You got it? Let's say this response test is significant. Then you need to use this t-test here. Do you see that? Corrected degree of freedom, not 22, it's 21.5. This is what you need to report. But since it's not significant, so I'm reporting this in writing. Okay. Then the 95 confidence interval, you could report this, or more accurate one, more robust one that they're recommending these days, which is new to me too, is bootstrapping based one. So first one, we did outlier test and normality test by group, t-test along with homogeneity. Effect size now here. Standardizer, cohesity, read cohesity. This is the concept that we learned. Then point estimate, absolute value. You don't have to worry about the directions. And if it's near to 8 or above, it's a pretty large effect size. And it's pretty large effect size, as you can see here. But statistically, not significant, as you can see. P-value is above 0.05. So this is a finding. Effect size could be large, and it could be statistically insignificant. Statistically significant, but effect size could be pretty small too. So it's possible. It's not like something that unusual, okay? So then last one, so we did outlier normality test, then test along with the homogeneity, then calculated effect size. Yes, it automatically calculated, which is good. Now we need to learn how to present these group differences in graph, okay? So as I am staying here, I'm going to go graph. So graph and then chart build, and you have to say okay. Then click the first one, then click here. Let me shoot here. Y is dependent variable, and x-axis is your group. Did you put that in there? On the right-hand side, you have display error bars, then confidence interval. Click the confidence interval. This is the way to develop the error bar that your exercise physiology and the movement science use this one quite often, okay? So pick confidence interval, 95%, and then paste it. It's pretty lengthy, the syntax, and so that you can have it and then make a note for yourself. And I'm gonna just say, okay. Then this is the figure that you will present to show group differences. Confidence interval, bar, and the mean scores. Here is a catch, okay? Remember this. I oftentimes see students presenting it, say, oh, it's statistically significant, and then figure looks like this. This is not statistically significant. Conceptually here, if confidence interval range bar overlaps like that, okay, then it's statistically insignificant. You got it? So when you are presenting, you say, oh yeah, statistically significant, then all of a sudden your bar is overlapping this, like that, then there's something is wrong with your data or the way you analyzing your data. Okay, so that confidence interval should not overlap. If they overlap again, that means what? Statistically insignificant. I explained exactly the way I'm showing you on the PowerPoint lecture slide too. Question? Over here. Yeah, step 1, 2, 3, that's what we did. And then I have annotated information, what I just went through here. Then how to report, I included it right there. What do you mean paired t-test? This is the best one. When I summarize this, I kind of liked it myself. Like, oh, yes, it's clear. It's always, remember, I highlighted it. Same individual did pre-post. So I did pre and I did post. It's a paired. It's my data, but it's a different time point. Two different conditions. So I did control without diet, exercise, with diet, exercise. Okay. Another one, I love this example one. Number 3, which I have a same from movement science. It's the same subject, and then they want to see my right leg performance and left leg performance. Got it right here? That's right there. And then you use the same person to measure VO2 and RPR to see the reliability of those together. Those are all paired t-tests. And quite often it is used in exercise physiology and movement science. Okay. And if it's a cross-sectional, what does that mean? They have separate group. That's what they use quite often. Cross-sectional something design means it's not repeated. They have group A with VO2 max, another group for RP in, and they are just comparing that relationship. So that's a cross-sectional. And repeated measure has a lot of benefits for certain research design. That's why they're using it. And before we get to repeated ANOVA, we're learning repeated paired t-test because it's only 2 times. If the time point becomes more than 2 times, then it becomes one way repeated ANOVA. Okay, so since this is only 2 times, we're using t-test. Got it? That's a concept. All right. Most important one here, right? Independent t-test, data entry. So remember this, data entry is a key for appropriate analysis. So independent t-test we did, look, it's all one, group 2, group 3, then all dependent variable 1 row. That's fine, okay? But with the same data, look at that, paired t-test. This is group 1 data. This is group 2 data. If you do 3 times group 3 data, so entering data, it should be absolutely different. So when you are designing your research design, like how you're going to collect the data, that already determines how you are going to enter the data. I made this step-by-step on the slide number 21, so I want you to stay there when I am sharing my SPSS program, okay? All right. So first step, we're going to calculate the difference between these 2 data, okay? So what do? We can just write up compute equals clock minus, no clock minus clock. Then it just develops, like it calculates. Or we can do it transform, compute, got it? And difference, right? Do you see the difference? It's I have to create it. Just a name that we can come up with. You can just say differ or difference, then clock minus, no clock minus clock. Then paste it and run it. This is just calculated. Differences between first try and the second try. That's the one. And then here, remember this, it's important. When you are doing outlier test and normality test, which one do you use it? This data. So first step is done. moving second step, I want to create mean score between first condition and the second condition and a mean score. All right, how do we do that? I compute, okay, reset. And then I'm gonna just say mean, okay? And then, are you with me? Under the function group, say statistical. Then you will see options there. Then you just say means. Got it here? Then, oh, 2 question marks. So you start the moving. Okay, I'm gonna right click, change that. Okay, so move to here. Then comma, right there, get rid of. I'm gonna change the name here, mean 2, so that you can see it's calculating. Oh, maybe I should make it mean S. I'm gonna put 1 S there, different target variable name. Did it? Then you paste it, then it'll look same as the one that I put it on slide 23. I'm going to just say okay. Then do you see that? This is just get calculated, which is the same as means here, which is I did it previously. You will see what we are going through. There is a reason for that later on. Now we're going to do adjustment, okay? And we need to calculate this adjustment so that we can do this too, which we need for drawing later, bar graphs, okay? So adjustment, how do we calculate it? Let's get descriptive. You put that mean. Oh, let me just move that. And then paste it. I'm gonna say okay, okay. What is the mean score from the output you did? Mean over mean, that's what I'm saying. Mean, we need a grand mean over means that we just calculated between 2 conditions. What did you get?
4.37.
4.375, okay? So now, have that on the side. We're moving, analyze, compute variables. So I'm gonna put it here. Do you see my dialog again? That compute dialog? Okay. Now I'm going to say new variable, which is adjustment equals, all right, the mean score. Just to say, what is it? 4.375, which is grand mean over mean, negative mean, which is the this variable that right after difference. Got it? Then paste it. Adjustments. This is what I just created, which is the same as adjustment here. We're going to do 2 more steps, then go paired. Original data, difference between 2, means between 2. Now adjustment a little bit so that we can create this final 2. And then you will really see why it's important to create these 2 to show the group differences in the figure. Okay, without it, it looks so weird. That's the one that I have oftentimes witnessed from our students, statistically significant, but their figure looks insignificant. That's why it happens. All right, now we're going to create this to adjusted data of these 2 original data. Okay, so now the compute, then I am going to reset. Now we're going to create those 2. So we name it, so clock adjusted, then clock data with that adjusted data. We are what we are doing right now is we are removing existing individual differences, not condition differences at the moment. So that when we put them in a figure, it really represent condition differences, not existing individual differences, right? So then you paste it, then I'm going to just say, okay, then you will see it developed, like created. That's exactly the same as the next one because it's the same calculation. Got it? Then you do the same for no clock also. So compute, now you put no underbar, then here, instead of the clock, you put no clock there. Then paste it. That's what I have also on page 23. And then paste it for yourself, and then I'm going to say okay. Then as you can see, created, same data as this one that I already created. Got it? So eventually your data should look like all this. All right, now go analyze, compare mean. Now we're doing paired. Opened up. Yep, this open up. This is a dialog here. Do you see that? Now you move. Okay. Oh, it's already there. Okay, I'll reset it. I'll move it again. Clock to one variable, clock to another variable. So that it can run paired t-test. Options, not much. I'm going to keep the interval, confidence interval right there. If you want to run bootstrapping because you feel like it has some issues there, then you can do the bootstrapping. And bootstrapping, again, for confidence interval, highly recommended, okay? Then do you see that estimate effect size here, automatically calculating? Click that. It's, it's clicked by default. So just keep it. Then paste it. And I'm going to run it. Pair the t-test here. Do you see the output? So pair the t-test, mean between two. Then pair the sample correlation. Correlation goes between two. I mean, you don't have to read it, but pretty high. Pair the t-test, mean, standard deviation, confidence interval, t value, negative 3.8, degree of freedom, and p-value. Is this significant or not? Yeah, right? So now we want to show this one in the graph, group differences. Okay. So let me before I go there, that's the last step. If you run t-test with original data, do you see that my data here? Then adjusted one, it's identical output. So the reason that we did all the way first this one to test outlier and normality, and this two to draw a figure to show that statistical differences in the bar graph, okay? So you will see. Last step here. So statistically significant, one is higher than the other. Now we want to show in the graph, that's the presentation of your output, right? So now graph again, last step, graph, chart build, and say, okay, I'm gonna move all four of them. No, just put that back in, okay. Then the default is a simple bar count here. And you can just move the last one, but I'm doing all four so that I can compare for you, okay? So you can move at the same time, all in same place. Then display error bar. Then I am going display error bar, confidence interval. You see what I'm doing here? And you can paste it, and it's a lengthy chart build syntax. I'm going to say, okay, then I'll compare for you. This is from the initial data, not adjusted, raw data, okay? Look at this confidence interval bar. Like the first one, that when we use the same data for, independent t-test. Confidence interval bar overlaps, right? But when we ran paired t-test, what happened? Here, significant. We are not representing the data correctly in the bar. to be able to do that in the repeated measure, we need to get rid of what? Potential individual differences. Some people already misbehave before read without even clock, okay? So that kind of differences has to be adjusted and removed. And when we adjusted data, look, this is a confidence interval. Do they overlap? No, it's clean right there. They are not overlapping at all. And statistically what? Significant. This is the step that we went through to be able to do paired t-test first, then difference for outlier low modulated test, then adjustment, all that to create this two so that we can represent properly the group differences in the bar graph. Got it? That's a step 1 through 5 that we did data so that I can show you one more thing. Descriptive, explore, reset. Can you put, okay, let me just go here. So the difference here. Then induce stats, outlier test, say continue, plots, normality, and okay. Then you just say paste, or you can do okay. Skinny kurtosis is pretty strong. So I do not worry about normality test for this data. I looked at skinny kurtosis, then I looked at KS test was significant, but Shapiro-Wilks, not significant, which is a more sensitive one. Then when you looked at QQ plot, pretty staying little, although it's a little bit off. So normality is good, and approximation is good enough for paired t-test, paired t-test. So I do not worry about it for this data.